All right, hi everyone, this is HPC 2.6 notes for rational functions and their graphs. All right, so what is a rational function? Remember that rational means fractional. So these are going to be functions that have x's on the top and on the bottom of a fraction bar. And more importantly, if they have an x on the bottom, they're considered rational. So even the equation 1 over x is considered a rational function. All right, so we're going to go through a lot of the same things we did with polynomials and quadrilaterals in terms of trying to graph them. And so we're going to go through a few of these. So the first one is symmetry. Now remember, there are 3 different ways to do symmetry. There is the one cheater way, remember in polynomials, that if all the powers are even, it's even, and if all the powers are odd, it's odd, keeping in mind that if there was a constant like a +2 at the end, that follows the evens, right? So that's the cheater way, but we don't have that here because these are fractional things. So we can't use the fastest way, the cheater way. So the other one was to look at it, but see, we're trying to use it to graph it to look at it. So we're kind of using it in the wrong order for that to work. So we are stuck with the algebra way for checking to see if something is even or odd. So here is the trick to this. To test for symmetry, okay, so I'm going to put it right here. So the test for symmetry is you start out by putting in a negative x everywhere where there is an x. So no matter where it is, you just put parentheses around it, make it a negative x. So that would equal, so f of negative x would equal 2 times negative x over negative x minus 1. And then you're just going to simplify basically the signs and simplify it that way. So doing that, I'll get a negative 2x on the top, and on the bottom, I'll get a negative x minus 1. Okay, first check is, does it match the first one? And remember that you might have to either multiply the top and bottom through by like a -1 over -1 or factor a negative out to see if it matches. But see, if I factor out a negative on the top, on the bottom it would be negative x plus 1, and then that won't match the top one. So the first check is, does it match the original? If it matches the original, it's even. Okay, the second check is a little bit trickier. The second check is, I'm going to compare it to negative f of x. And another way to say that is to just put a -1 in front of the entire function. So this is 2x over x minus 1. Okay, and we're going to see if what we got when we plugged in a negative x, the blue stuff, matches the green stuff. So on this one, I'm not going to distribute the -1 across the top and the bottom. It's 1, -1. So when I multiply it, I decide. So I'm going to put it across the top, so it becomes -2x. The bottom is still x minus 1. So now your second check is, does it match your blue stuff when you put in a negative x on the inside? If it does, it's odd. So in ours, it doesn't quite match. I get the -2x on the top, but I can't get the negative x minus 1 on the bottom. Even if I do a sign change or try to factor out a -1, I will not get that. So this one is neither. We just went through all those steps to find out nothing good. I promise we'll have the other symmetries as we continue on so you can see and practice those. So first step is always plug in a negative x, and then you're checking to see if it matches the original. If it does, it's even. If it doesn't, then your next step is you got to multiply the original by a -1 and see if that matches your negative x problem. And if it does that, it's odd. And if neither of those match, it's neither. Okay. All right. So how do we find x-intercepts? We set y equal to 0. Okay. And here's our little note thing over here. So the even function is foldable over the y-axis. The odd function is foldable over the origin. To find an x-intercept, we just have to set the top to 0, right? So if I'm going to check for x-intercepts, I'm going to set the top equal to 0, so 2x equals 0, so x equals 0. So we do have an x-intercept at x equals 0. Okay, so we did that one. To find the y-intercept, we plug in an x. So to plug in an x to the original, I would have 2, plug in a 0, over 0 minus 1 is going to be a 0 over -1. So that looks like that's going to simplify to a 0. 0 over any other number is a 0. Just be careful if you ever get a 0 over a 0, that's trouble, okay? So y-intercept is y equals 0. All right, next step is, how do we find asymptotes? Okay, so vertical asymptotes. These are also called VAs, vertical asymptotes, okay, VAs. Okay, to find a vertical asymptote, you're going to set the bottom equal to 0. Okay, so I'm going to do x minus 1 equals 0, solve it, and I'll get x equals 0. Okay, that tells me that sorry, I did not do that right. Let me try that again. If I set x minus 1 equal to 0 and then solve for x, I'll get x equals 1. That means that there's a vertical asymptote at x equals 1. Okay, let's plug in what we have so far so that you can see it. All right, so we have a vertical asymptote at x equals 1. This is where x is 1, so I just put a little slashy line through the whole graph to show that's a vertical asymptote. And if you want to, you can even label it at the ends. Okay, the other one was we're going to put a dot at x equals 0 and y equals 0. Well, that's going to be the exact same dot. That's going to be this one right here. Okay, that's all we have so far. All right, so let's keep going. Okay, check for holes. So if we ever get that 0 over 0 that I talked about when you plug in an x, okay, so when top and bottom equals x or equals 0, when, let me change the color, when you plug in x equals 0. If you get 0 over 0, then that could mean that there is a hole. And all that means is the graph just exists the way it normally does, but there's just like this open hole somewhere in the graph, okay? All right, horizontal asymptotes, we call those HAs, H-A's. Okay, horizontal asymptotes are always going to be a y equals. Now this one depends on your highest degree of x. Highest degree on the top versus highest degree on the bottom. So let's go look. Okay, in mine, my highest degree of x on the top is a 1, and on the bottom it's a 1. So in my case, my degrees match each other. So that's the equals one. So when they equal, you're going to take the coefficients in front of each of them. Okay, so in my case, we're going to have y equals 2 over 1. The coefficients in front. 2 over 1 is a 2. So I'm going to have a horizontal asymptote at y equals 2. In our case, we do not have any holes because we did not get a 0 over 0. So now I throw in a horizontal asymptote at 2. That is right here. Horizontal asymptote at 2. Okay, horizontal meaning the line you create is horizontal, and the equation is a y equals 2, which if you continue it and extend it on either side, it ends up going horizontal. All right, so here's the thing with rational functions. They never, ever, ever cross a vertical asymptote, ever, ever. Okay, so I'm going to go and put a star next to that one. It never, ever, ever crosses. So the graph does not cross a VA, okay? But a graph sometimes will cross an HA. And it will do this sometimes if there is 3 or more sections. And so in our case, we have 2 sections. So I'm going to say 3 or more sections, and I'm going to say vertical sections. Okay, so in our case, we have, let me highlight it for you. Here is section 1, and here is section 2. So I only have 2 vertical, right, sections. So it's not going to have any weird stuff happening on the horizontal asymptote. Okay, so what we have to do is I know that it's going to stay put for where it is. So this dot over here is going to work downwards. Let me turn that into a regular pen. Is going to work its way downwards towards the vertical asymptote. So once we have it going generally in the same way as the VA, we put an arrow on it. And then the other way, it's going to turn and it's going to come across towards this horizontal asymptote. So it's going to kind of fill up the space or the section it's in between horizontal and verticals. Now what I don't know is I think there's another one somewhere else on this graph. Okay, so the question is, could it be up here? Well, if it is, then it's not a function, because remember, for every x, there has to be only one y. So to put any graphing stuff up there, I would have to use the same x that I used on the bottom part and get a different y, and that's not possible. So that means that there is more graph happening on this side somewhere. So I need to go find those. So the way I go find those is I'm going to go do an x, y chart, and I'm just going to plot some points between the x and y intercepts. Okay, so I'm going to change that notation to say I'm going to go and find plot points between x-intercepts, vertical asymptotes on either side of vertical asymptotes. Okay, so we already have a dot on the left-hand side. We're good there for a quick sketch. On the right-hand side, I just need one of those x's to figure out whether it's going to be in that top section or whether it's going to be in that bottom section. Okay, so I'm going to set up an XY chart. I'm going to do this one horizontal just because I have more room going this way. And we already know 0 worked. We already know we're not allowed to use a 1 because there's an asymptote there. So let's go and try a 2. So I'm going to plug this into the original equation. And the original equation was 2x over x plus 1. So 2 times 2 over x minus 1, which would be 2 minus 1, be 4 over 1, or 4. So I'm going to plot the point 2 and 4, that's up here. So what that's going to tell me now is that the rest of my graph is located in between those two parts. So on the uphill slant, we're going to have it go towards the vertical asymptote. On the downhill slant, we're going to have it going towards the horizontal asymptote. Okay, and this is a typical behavior for rational functions. Anytime that you have an x on the bottom, they're going to create vertical asymptotes. And then the graphs are going to be curvy curves that are going to be left and right. There's going to be a left portion and a right portion. All right, so that's really all there is to it. So we're going to go and just practice a few more. Okay, so in this one, let's see. In this one, let's take a look for symmetry on this one. So remember, the key here is to start out with a negative x and plug it in. So if I plug in a negative x, I'm going to get 4 times negative x over negative x quantity squared minus 1. And when I simplify that, I'm going to get negative 4x over positive x squared minus 1. Okay, does that match the original? No. It does not match the original, so it's not even. Okay, so if it matched this, we would have said even, but it's not. Okay, so then the next thing we try is we try what happens if I put a negative in front of the original. So negative 1 in front of the original. So remember, when you put a negative 1 in front, you're either going to multiply across the top or the bottom, but not both. So if I do that, I'll get a negative 4x over x squared minus 1. Notice that this does match what happened when I put in my negative x, which means that this is odd. So my symmetry is odd, which means it's the rotational symmetry around the origin. So if I have points in first quadrant, I'm going to have points in third quadrant. If I have points in second quadrant, I'm going to have points in fourth quadrant. Okay, so it's going to be spinnable 180 degrees. So I already know it's odd. All right, next one. Let's go and see if we can find our x-intercepts by setting y equal to 0. And setting y equal to 0, setting the top equal to 0. So 4x equals 0, x equals 0. Find the y-intercept by setting your x equal to 0. So if I set x equal to 0, I'll get 4 times 0 over 0 squared minus 1, which will be 0 over negative 1. So I will just get a y-intercept at y equals 0. 0 over 1 is 0. Okay, vertical asymptotes. So for vertical asymptotes, remember, I'm looking in the denominator and setting it equal to 0. So x squared minus 1 equals 0. So I get x squared equals 1. Now remember, x squared means there's going to be two solutions, right? So if I put a square root around this, I have to remember to put a plus minus in front of the square root around 1. So I'm going to get x equals plus or minus 1. So I have two vertical asymptotes. I have x equals negative 1 and I have x equals 1. Okay, let's go plot what we have so far. So here is a vertical asymptote at 1. Here is one at negative 1. I'm going to put little VAs above each one. Okay, and we also have the coordinate point 0, 0 in our graph. Okay, all right, so what's our last thing is, do we have any holes? No, we got 0 over negative 1 when we plugged in 0, so we have no holes. And then for horizontal asymptotes, remember, this is the battle of the x's. We're going to look at the powers of the x's, and the power on the top is a 1. So we have a degree of 1 over a degree of 2. Okay, so let's go back up to our first page and see what happens when the top is less than the bottom. So we already did one that was equal. Now we have one where the degree on top is a 1, the degree on the bottom is a 2. And any time where the bottom outranks the top in terms of degrees, you will have a horizontal asymptote at y equals 0. It'll be in the same place every time. Anytime where the bottom degree, the highest power of x, is bigger than the highest power of x on the top, it will be 0. Okay, so that is what's going to happen here. We're going to get a y equals 0. So we're going to get y equals 0, and that is our HA. So I'm going to put a little dashy line this way. And you're like, wait a minute, you just put a dashy line through the 0. So remember what I said about graphs do not go across or through vertical asymptotes, but they do sometimes go over horizontals. And that's because we have 3 sections. Okay, so let's show you where those sections are again. So we have this section right here where there could be a graph. We have this section right here where there could be a graph. And we have this section right here where there could be some graphing. Okay, so they're going to stay within those 3 colored regions. I just have to go and find some points for them. All right, so I don't even know what's going to happen in the middle because I don't know what that looks like. It could look like a x to the 3rd that goes up this way. It could look like a parabola that opens up or opens down. Okay, so let me erase those and we'll start looking at the left side of things. So on the left side of things, so we need a table of values. Okay, so here we go for table of values. Ooh, hello, table of values. All right, we already know 0, 0 existed, right? Let's try for something on the far left side. So far left side, remember, I'm going to have to plug it into the equation, so don't make it too big. I'm going to try a -2. Okay, so it's just like one whole step away from that asymptote. So when I plug in a -2 into the top, I'm going to have -8 over -2, the quantity squared, minus 1. So that's going to be -8 over 4 minus 3, or 4 minus 1, which is -8 over 3. So that's -2 and a little. So at -2, I'm going to go down 2 and a little. So 2 and a little. It's going to be right about here. Okay, so again, because of where it's located, because it's under the horizontal asymptote, I know this part is going this way. I know this part is going this way. Okay? The outer edges always work the same way. They look the same way. They look like little U shapes. You just have to figure out whether they're up top or on the bottom. So the next one I'm going to try is +2. I'm going to do the exact same thing. So the top is going to be 4 times 2. That's a +8. And the bottom is still going to be a 3. So we're still going to have 8 over 3. So that's now +2 and 2/3. So we're going to go for 2 and 2 and some, right about there. And again, we can see that this one is going to be this part here, and then it moves over towards this part here. Okay? All right, so what's going to happen in that middle spot? So in that middle spot, I'm going to change the color, and we're going to go try something. Now, my problem is I've got asymptotes at 1 and -1. So I got to pick something somewhere between 0 and 1 or 0 and -1. So I'm going to pick a 1/2, and this could get a little bit messy. Okay, so the top part is supposed to be 4 times a half. I can do that. That's a 2. The bottom part is supposed to be 1/2 squared. Ugh. 1/2 squared is 1/4, right? 1/2 times 1/2. 1 times 1 on top, 2 times 2 on the bottom, 1/4, minus 1, and since we're going to be subtracting with fractions, I'm going to call it 4 over 4, which is still 1, but then I'm ready to do common denominator on the bottom, okay? So now I have 2 over -3/4, okay? And now I'm going to turn this into multiplying by the reciprocal. So I'm going to do 2 times 4/3 with a negative sign somewhere, is going to be -8/3, -8/3. Okay, so -8/3 when it's 1/2 is going to be -2 and some, so right about there. And I now know it does this. Now here's the cool part where symmetry is going to help us. Remember how I said it turns 180 degrees, right? So if I would have turned this U shape over here 180 degrees, I would have gotten that shape. So I know those are good. So same deal here. If I turn this 180 degrees, I will get another one that goes up this way. So I can use my symmetry to help me figure out what the graph is doing. We know the entire graph is odd, so it entirely has that origin symmetry where you can turn it 180 degrees. Okay? All right, on to our next ones. Okay, it says on this one, it says list all the information, look at the table and graph on your graphing calculator and make a sketch. So we can get some other stuff done before then. Let's see what we can get done first. Okay, so let's test for symmetry. So remember, our first test for symmetry is just to plug in a -x wherever there was an x. So 3 times -x squared over 4 times -x squared minus 9. Simplify the x's and the negative signs. Well, a negative squared is positive, so the top is still going to be 3x squared. The bottom -x, the quantity squared, is still going to be positive, so I'm going to get 4x squared minus 9. Compare it to your original. If it matches, it's even. It matches. So we have an even graph. So we have even symmetry. That means it folds over the y-axis. That means once I do the right side, I can already figure out what the left side looks like. Okay? And that's the y-axis. That's not some vertical line anywhere else. It's just the y-axis. All right. So continuing from there then, we have x-intercepts. We find x-intercepts. Whoa, I wrote that in the wrong place. Let me go fix that. She gave me so much room for the other ones. All right. So we have even, which is y-axis symmetry. Y-axis symmetry. All right. Next step, to find x-intercepts, you set y equal to 0. Another way to say that is you're going to set the top equal to 0. So setting the top equal to 0, we would get 3x squared equals 0. That would be, the only way that works is if x is 0. Okay, so I'm going to go put a dot there. All right, next one, let's go find the y-intercept. We find the y-intercept by setting x equal to 0. So we're going to plug in an x is 0. So we're going to get 3 times 0 squared over 4 times 0 squared minus 9. And we're going to get on top a 0 and on the bottom a negative 9. So that is a y equals 0. So we're still at the same point at the origin. Vertical asymptote. To find a vertical asymptote, you set the bottom equal to 0 and solve. So 4x squared minus 9. Let's see, I'm going to call that 4x squared equals 9. Divide by 4. Now, those are perfect squares. So when I take the square root of these, it's just going to be square root of 9 over square root of 4. So this is going to be x equals plus or minus the square root of 9 over 4, which is 3 over 2. So there are vertical asymptotes on these at 1.5 and negative 1.5. So here is 1, here is a half. So these are my VAs. Here's a 1, here's 1.5. Okay, so again, I'm going to have 3 regions. I'm going to have to go and check dots in each section. All right, let's see, where are we next? So vertical asymptotes, we had x equals plus and minus 3 halves. Did we have any holes? No, we got a 0 over negative 9. We're good there, so none. Do we have a horizontal asymptote? Remember, this is battle of the x's. Let's go look at our degrees. Our degrees on top is a 2. Our degrees on the bottom is a 2. It is a tie. We have already done a tie. Whenever it's a tie, we take the coefficient in front. So the coefficient in front is 3/4. So tie of an x squared over x squared. So when we just look at degrees, they match. Then we take the coefficients in front. If the bottom wins, it's y equals 0 every time. All right, so 3/4 is going to be like, here's a 1, it's going to be just a little bit below it. So this is my horizontal asymptote. Okay. All right, so this is where she was saying it's okay to cheat and go ahead and use Desmos for some of the regular points and stuff. So let's see if we can do that. Hang on. So I just brought up Desmos. So we have our y equals ready to go here, and I'm going to type in exactly what we had. Now I have to be careful that anything in the numerator gets a grouping symbol, anything in the denominator gets a grouping symbol. So on the top, I'm going to have 3x squared, and then a divide sign. Good. Now I can tell it's going to look fine. And then the bottom is going to be 4x squared minus 9. Okay, so keep in mind that what I had already found was I already knew the 0, 0 was here. I already knew these vertical asymptotes were here. And I already knew this horizontal was here. So what she's saying when we say go ahead and use your graphing calculator to get some of these is I want to find a couple of these points. So I can use, just by clicking on it, I can use and try to go find some other points, right? So I can go and do -3, 1 is going to be one of my points. So I can now go fill that in on my graphing, and let me move this aside and go do that. So -3 and 1 was one of my points. So -3 and 1 is right there. So I know I have this one going this way. Okay, then let's bring it back and go look at another one. So if we had -3, remember again, we know it's even. So if -3 had a 1, then +3 has to have a 1 as well. Right, so there we go. So because it's even, I know it has to fold over that y-axis. So I know it's going to be up here at 3, 1. And we're going to have the same thing happen up here. Okay, what about in the middle? So in the middle, now I know what the behavior is in the middle, that it's going to be a U shape going down, and that it's going to be equal on either side, right? Because remember, because it's even, it folds over the y-axis. So I can click on here and try to go find a point here. Let's go find where 1 is. Looks like 1 is going to be at Oh, so close. Okay, I'm going to go try to find 2 then. Nope, not even. Okay, so I know it's got to be somewhere right around negative 0.6. Okay, so I'm going to go and put that on my graph, negative 0.6 on either side. So negative 0.6 doesn't even make it down to 1. So right about here for 1. So it's going to look something like that. Okay. All right. Let's go see what our next one is. This is our last and final one. So on this one, we're going to start again and check for symmetry. So we're going to plug in a negative x. And when I do that, I'll get a 3 times a negative x plus 6 over a negative x quantity squared minus a negative x minus 6. Okay, if I simplify that, on top I'm going to get negative 3x plus 6. And on the bottom, I'm still going to get an x squared, but now it's going to be plus x, and it's going to be minus 6. Notice the minus 6 didn't change because there's no x to help it change with the negative x in it. And then I'm going to try to go and compare to the original. So the original started with 3x. Now I can factor a negative 1 out of the top, but if I do that, I'll get 3x minus 6. So it doesn't look like to me it's going to match the original. So it's not even, okay? All right, so then the next thing I'm going to do is I'm going to go try what happens if I just put a negative in front of the answer, the entire thing. So if I do negative f of x, that would be just put a negative 1 in front of the whole thing. So now I have 3x plus 6 over x squared minus x minus 6. And if I distribute it to the top or the bottom, will it match this other one that I just found by plugging in a negative x? And I don't see that happening. If I distribute a negative 1 across the top, I'll get a minus 6 instead of a plus 6. So this is a neither. So this is a neither. Okay, and it's a neither because it doesn't match the original when I put in a negative x, and if I just change the answer with a negative sign, it doesn't match my negative x either. All right, let's go find some x-intercepts. That means I set the top equal to 0. If I set the top equal to 0, 3x plus 6 equals 0. I'll get 3x equals negative 6. I'll get x equals negative 2. So go put that on my graph. Let's go find the y-intercept. So y-intercept, I just plug in an x is 0. So I'll get 0 plus 6 on the top, 0 minus 6 on the bottom. So I will get a 6 over negative 6. Yes? 6 over negative 6 is a negative 1. So I'll have a negative 1. Okay? Vertical asymptotes. If I try to spend some time and set the bottom equal to 0, I'm going to have to move down a little bit to do that. So I'm going to go down into this blank space in here, and I'm going to recopy the function real quick. So I have f of x equals 3x plus 6 over x squared minus x minus 6. And I'm supposed to be looking for VAs, which means set the bottom equal to 0. Now, because it's a polynomial, I can try to factor it, or I can use quadratic formula. So I'm going to try to factor it. I think it's going to be x minus 3 and an x plus 2. Okay, and then while I'm here, if you're able to factor the top as well, if you already spent the time to factor the bottom, factor the top as well, and here's why. If the top has either one of those matching factors, we have just found the elusive word for a hole in a graph, an irrational function. So if I factor out a 3, I will get an x plus 2. That is a match. So now I know that there is a hole at x equals negative 2, and there's a vertical asymptote when I set the x minus 3 equal to 0. So x equals 3. Okay, now one of those I can go graph right away. The vertical asymptote I can go graph. So x equals 3, this is a vertical asymptote. Okay, this one I have to store for later, and remember that there is a place. So there's a couple ways to do this so that you don't forget it. So if x is a negative 2, I'm going to go over here to negative 2. So I'm going to go over here to negative 2. And I'm going to write the word hole above it instead of VA to remind me to make that into a hole later. There's a problem, right? Because there's already a dot on there. So that dot does not really exist there. It's an imaginary dot. It really doesn't belong there. We really don't have a x-intercept. That's just what we found out. We found out that negative 2 does not exist on this graph ever. So if negative 2 does not exist on this graph, there cannot be a point there anymore. So that means we get to go back up to here, and I'm going to turn it into a different color so you can see it. We're going to cross out. X-intercept is no longer -2. It isn't. It isn't -2 anymore. We thought it might be until we got to the holes question, and now we realize our life has just completely changed. Life is not the way we knew it. Okay, the other thing I'm going to do is I'm going to come down here, and I'm going to erase the orange dot that was here. It is no longer here. Now I'm going to leave that note because I still have one more thing that I have to do yet. Okay, all right. So we figured out there is a hole. We figured out it's at -2. Okay, we're going to continue on, but we still have to come back and deal with that hole. All right, so next thing we're going to do is we're going to go check out the horizontal asymptote. So this is battle of the x's. Let's go see which x has the highest power. It is the bottom one again. So anytime it is the bottom one, I'll scroll back up to the top part. Anytime the degree on top is smaller, that's the second one right here, we're going to write y = 0. So we have a horizontal asymptote at y = 0. Plug that in. It's going to go this way. All right, and this is HA. All right, so now again, we're going to go ahead and use a graphing technology to help us graph some of the other points. The only one I really have right now is that green one, and I do know that the symmetry on this one is a neither, correct? So I really don't know what this one looks like yet. And that would kind of make sense to me that it can't be any kind of symmetry if we have a vertical asymptote over here at, what is that, at x = 3, right? I can't really have it be rotational, and if it was reflection over the y, I'd have another line where I know there's a hole right now, so it's not going to be symmetric. All right, so I'm going to bring in the graphing calculator, and I've already graphed it, and I want you to see that I also put the point -2, 0 on it. Can you see why that cannot possibly be on that red line, and why we erased it once we found out there was a hole? Okay, so I'm going to go over here and I'm going to look for a point maybe to go with 5, and it looks like 5 is 1.5. So I'm going to go and graph that on my graph, 5 and 1.5 as a coordinate point. So 5 and 1.5 would be right about there. I get that point. So I know that there is a graph over on this side that is doing this. That's the easier part, right? Because it's nowhere near that hole. Okay. All right. Next, let's look for something in the other side. Now, the other side I actually do. I don't have 3 sections this time. Okay. So this time, this dot right here is already part of mine. That's going to go this way. So you can see that it goes this way. So I'm going to use that green dot that we've already plotted, and we're going to use it as if it's going towards this vertical asymptote and towards this horizontal one. Okay, so it doesn't look any different than before. We had our left side, we had our right side. Here was the left side, here was the right side of the vertical asymptote. We only had one true vertical asymptote. So we found points on either side and graphed it, okay? All right, so let me erase those and then let's talk about that hole. All right, here's the problem. If I were to go, and we know that that hole is at -2. So if I were to go to the original problem, so over here, original problem. Okay, so if I were to go over to where x is -2, and if we put it into the original, we'll have 3 times -2 plus 6 over -2 squared minus -2 minus 6. And if I go to simplify that, I'll get -6 plus 6 on the top. And if I do that on the bottom, I will end up with 4 plus 2 minus 6, which is 0 over 0. This is bad news. We should not be getting zeros over zeros. And we kind of knew that already, right? So if I go and I plug it into the factored form instead, so factored form means that I can cross out that x plus 2 on the top and x plus 2 on the bottom. So on the top, we'll no longer have an x to be plugged in at all. It'll just be a 3. And on the bottom, we'll plug in a -2 minus 3. And that will give us 3 over -5. So that is about -0.6. Okay? So when x is -2, y would have been at -0.6, except for that idea that -2 no longer exists in this graph ever. So when I go and put in a hole onto my graph, I'm going to try to go put a hole over at -2 and -0.6. And hopefully my sketch has already put it pretty close to there. So -2 is right here, -0.6 is going to be right here. And I'm just going to go put a hole over that section to remind myself that there is a hole there. Okay, if I bring Desmos back over, I'm not sure if it'll do this very nicely for me, but if I try to go onto the graph where it's 2, will it let me? Will it let me? See, it'll say undefined. See that? It's even drawing an open dot on the graph itself. Do you see it? Okay, so it's saying -2 does not exist on this graph. Do not use it. It does not exist. All right, so that's what happens when we find a hole. All right, so you just draw a hole on it at the very end. Just don't forget to do it. So the last thing we have not talked about is what do we do on that last battle of the x's for horizontal asymptotes. So we've handled what do we do if they're equal for coefficients, what do we do if the top is smaller than the bottom, and if the top is bigger than the bottom, that is going to be no horizontal asymptote at all. Okay, so no horizontal asymptote at all. All right, that's it. You guys, we'll talk to you later.